Hello my dear students, welcome back to the lecture series of differentiation of functions. This is our lecture number 2 and in this class we are going to discuss about the differentiation of implicit functions. And implicit before beginning of this chapter, first of all we are to know about the implicit function. What is implicit function? These types of function is actually in these types of function in general the variables x and y cannot be separated easily, but in some certain conditions it may be separated, but in general in implicit function x and y cannot be separated. So first of all we write the definition and procedure of differentiation of implicit functions. So let me write that. Here you see the functions of the form f x y equal to 0. Here x and y both are inside some functions f is equal to 0. In these types of function we say the function is in implicit form. So in which the variables x and y cannot be separated easily are called implicit functions. That means where the variables x and y cannot be separated easily mean in some certain conditions you can separate the variables x and y also, but in general they cannot be separated easily, and these types of functions are known as implicit function. So to differentiate an implicit function we are to differentiate the entire function, the given function, entire function without any modification. You directly differentiate the function either with respect to x or with respect to y. Any variable, with respect to any variable you can differentiate them, and after that you should collect all the terms involving dy dx, because after differentiation, completion of the differentiation, then there will be some terms involving dy dx if you take the differentiation with respect to x, and it will contain dx dy if you differentiate with respect to y. So you collect all terms involving dy dx or dx dy in the left hand side of the equation, in the left hand side of the equation, and after that you take common dy dx, and all of the terms which are free from dy dx shift to the right hand side of the equation. Then take common dy dx in the left hand side, and by dividing you can find dy dx very easily from the equation. So this is the rule for finding the differentiation of an implicit function. So let me take some examples for these types of function. So find dy dx of the following functions. This is the first question. Xy plus y square is equal to 10x plus y. So this is an implicit function because you see you cannot separate x and y. That means you cannot express this total function either in terms of y is equal to expression for x or x is equal to expression of y. You cannot express this equation in that type. You see, if you take this y in the left hand side, take y common, then it will be y into x plus y minus 1. So then y is equal to 10x by x plus y minus 1, and x plus y minus 1, y is going to the right hand side again, and therefore y cannot be separated from x in this equation, and hence it is an implicit function, purely implicit function. So the process was how to differentiate an implicit function. Just you directly differentiate this function with respect to either x or y. In general we differentiate with respect to x. So you should write this line, differentiating with respect to x. This is compulsory. When you are differentiating an implicit function, you are to write this line. So differentiating with respect to x, you see this is our function xy plus y square is equal to 10x plus y. So first differentiate x into y. This is a product function, x into y. So first differentiate x, y will remain same, plus differentiation y, x will remain same. That is product rule of differentiation apply here. So differentiation of x is 1, y is remaining same, so it is simply y plus. Now x is remaining same, differentiation of y with respect to x is dy dx. So xy differentiation is y plus x into dy dx. Very simple. Then plus, it is y square form. So to x to the power n form derivative is n into x to the power n minus 1. So y square will be equal to 2 into y. But since this is not x, therefore by chain rule, differentiation of y is dy dx is equal to, this is 10x. 10x differentiation formula is sec square x. No chain will be there because the primary function is in x and here also it is x. Then plus y differentiation with respect to x is dy dx. Now the method is to collect all terms in the left hand side involving dy dx, that is this term and this term to be kept in the left hand side, and the term free from dy dx should be kept in the right hand side. So you see here dy dx is equal to, implies dy dx whole into, I am taking common in the same line, dy dx. Here x will be there, here 2y will be there, and this dy dx shifted to the left and taken common, so it will be minus 1 is equal to, on the right hand side sec square y is already there and this y is shifted to the right hand side, so it is minus y. Now just divide by x plus 2y minus 1. So dy dx will be equal to sec square minus y divided by this term, and this completes the solution of the problem. So let me take another question. This is your second question. Y plus sin y is equal to cos x is also implicit function because the dependent variable y is inside sin. This is y is inside sin, mean it is an implicit function. You cannot separate y from x here because cos x, this y is shifted to the right hand side, so cos x minus y, then this y will be equal to sin inverse cos x minus y, and that will involve again y. That is why y cannot be separated from x from this equation, and so it is again an implicit function. So here also you write the line differentiating with respect to x. So differentiating with respect to x, so this y differentiation will be dy dx. Sin y differentiation is cos y, but it is y, so into dy dx by chain rule, and on the right side cos x will be minus sin x only. So you see y differentiation is dy dx, sin y is here, sin y differentiation is cos y, and for y you are to write into dy dx equals to, this is cos x, the formula of differentiation of cos x is minus sin x. Now collect dy dx, take common and divide it. To dy dx whole into, it will remain 1, then plus, this is cos y, and right hand side is minus sin x. Simply dy dx is equal to sin x divided by 1 plus cos y, and minus will be there. So this completes the solution of the problem. You take another question. X square plus xy plus y square is equal to 100, and this question is homework for you, and it is also simple. You see x square differentiation will be twice x, and xy product function x differentiation 1 into y plus x into dy dx will be the differentiation of xy. It is already discussed in the earlier screen. And then y square differentiation is 2y, then for y into dy dx. Then the method is same. You just collect the terms dy dx in the left hand side, other terms should be shifted to the right hand side, and from there you can find dy dx. Differentiation of 100 will be 0 because it is a constant. Ln constant differentiation is 0, you know. Okay, so let me take another question. X cube plus y cube is equal to 3x square xy. This is our question. Implicit function, obviously. So you directly differentiate this function. This is our function. So differentiating with respect to x, x cube differentiation is 3x square, you know this. Y cube differentiation 3y square, this power will come in front and power will be decreased by 1. So this is 3x square, this is 3y square, but it is y, not x. So therefore you are to write the differentiation of y also, and so by chain rule into y differentiation is dy dx equal to, here thrice a is constant, so thrice a remaining same, So our function is now x into y. This is product again. So x differentiation is 1 into y remaining same plus x is remaining same, y differentiation is dy dx. Simple. You got my point. Then 3 will be cancelled out. It's 3, 3 and this 3 will cancel. Complete this product and shift the term dy dx in the left hand side. So it is simply x square then plus y square dy dx is equal to ay then plus ax dy dx, and just shift to the left. Dy dx is common here. From this term y square is remaining, and from this term minus ax is remaining. To the left it will be negative, so minus ax is remaining, is equal to ay is already there. This x square is shifted to the right, so minus x square. From here dy dx is equal to ay minus x square divided by y square minus ax, this one. So this completes the solution of the problem. This is another question. X cube plus y cube plus 4x square y minus 25 is equal to 0. Method is similar to the previous question again. So differentiating with respect to x cube differentiation is 3x square, y cube differentiation is 3y square, but for y you are to write dy dx plus here product function 4x square is one of the function and y is another function. So 4x square differentiation, this 2 will come out, so it will be 8x into y is there plus 4x square is there, and y differentiation is dy dx. 25 is an Allen constant, so it will be 0, and on the right hand side it is obviously 0. So this is the differentiation. You got my point. This is 3x square, y cube is 3y square dy dx plus this 4x square derivative is 8x into y remaining same plus 4x square remaining same, y derivative is dy dx, 25 0, and right hand side is obviously 0. Then collect the terms dy dx. This dy dx is common here. This is thrice y square, and from here 4x square equal to minus 3x square. This is minus 3x square and minus 8xy. So this is minus 8x. Minus is taken common on the right hand side. Okay, then dy dx will be equal to just division by this term, and it completes the solution of the problem. And this is homework for you. You can solve this problem. A and b should be taken as constant. That is, it is ax differentiation is a only, by square differentiation 2b into y, then y dy dx. Cos y differentiation is minus sin y, and for y you are to write into dy dx. Then collect the terms dy dx in the left hand side, and from there you can find the derivative of the function very easily. Okay, then you take the next question. X cube plus x square y plus xy square plus y cube is equal to 81. Simple, direct. Write the line differentiating with respect to x. So it will be 3x square, you see here 3x square plus here again two functions are there, x square into y. So x square derivative 2x, y remaining same, plus x square remaining same, y derivative dy dx, plus here x into y product function again, x derivative is 1 and y square remaining same, plus x is remaining same, y square derivative is 2y, and for y dy dx, plus y cube derivative is 3y square, and for y you are to write dy dx equal to 81 constant number, so derivative is equal to 0. Okay, so now collect the terms dy dx from these three terms, and this one and this one to be shifted to the right hand side. You see here dy dx, it is x square 2xy 3y square equals to this and these terms are negative, so taking minus common here, 3x square plus y square and plus 2xy. Then just divide by this term to the right hand side. So dy dx will be this one, and that will be the answer for the question. This is a new question. Ax square 2hxy plus by square 2gx plus 2fy plus c. This is actually a general quadratic equation. This is a general quadratic equation. So you differentiate this one, take the solution differentiating with respect to x. So a, h, b, 2z, 2f and c, all of them should be considered as constant. So x square derivative is twice x and written as 2ax. A is constant, so remaining same. So 2ax plus 2h is constant, remaining same. X into y is the product function. So x derivative 1, y remaining same, plus x is there, y derivative is dy dx, plus this by square, y square derivative is 2, so 2b into y, and then y derivative is dy dx, plus twice z remaining same, x derivative is 1, so it is twice z, plus twice f remaining same, y derivative is dy dx, and c is alone constant, so derivative 0 and equal to 0. Now complete the product, and this 2 is cancelled, 2 2, this 2 2 2 will go, and take common dy dx. So dy dx, here dy dx is present, so it is hx dy dx. Dy dx is taken common, so hx is remaining there. 2 is already cancelled, dy dx, so by will be there, and here 2 is already cancelled, dy dx, so f will be there. These three terms, hx, by, f, and the terms this hy and this 2 z only will go to the right hand side, and taking minus common because all of the terms will be negative. So it is ax negative, this is minus hy, this one, and this is minus z is this one, and just divide it, will be the solution for the question. X into y minus x whole square then equal to x plus y is the question, and this is homework for you. This question is homework for you, and I am going to solve this 9-number question. Okay, and it is homework for you. Similar method, these two methods, same questions actually. So here you see x into y minus x whole square is equal to x plus y. Here you see, first of all, there are two functions. One of the function is x and other function is y minus x whole square. So mean here is a product function there. So differentiate the product function. You should use the product rule of the differentiation. You already know, first function derivative, second function remaining same, then second function derivative, first function remaining same. Okay, so write differentiating with respect to x. You see, first function is x, x derivative is 1, so y minus x whole square remaining same, plus this time x is remaining same, and here y minus x whole square derivative, so outer function is whole square, so 2 will come out, 2 into y minus x to the power 2 minus 1 is 1, need not to write there, so x remaining same, this is twice of y minus x into, this is considering total term as x, y minus x is considering as x, so therefore by chain rule this y minus x should again be differentiated, and that is y differentiation is dy dx and x differentiation is 1. Minus is there, is equal to right hand side, x is 1 and y differentiation is dy dx. Is it clear? Okay. Then complete the product and take common dy dx on the left hand side. So dy dx, here it is twice x into y minus x, this one, and this term shifted to the left, so it will be minus 1 because dy dx is taken common, is equal to 1 is already there, this y minus x whole square is negative on the right hand side, then after completion of this product it is negative twice x into y minus x, but shifted to the right, so it is positive twice x into y minus x. And just divide it, just divide it, and it's a very simple calculation is there. So dy dx is equal to, complete the product, 1 this y square minus twice xy, but it is minus, so plus twice xy, and here also twice xy, mean 4xy, and it is minus x square, and here minus twice x square, so minus 3x square, it is 2xy minus 2x square, and minus 1 is there, and it completes the solution. This question is homework for you, you solve the question. Okay, again these two questions, I am taking these two questions, and this is homework for you. I will solve this question for you. So xy is equal to cos of x plus y. Here product rule will apply because x into y is there, so product rule apply, and cos function derivative you know, and there will be chain rule because cos of x is the primary function, but here it is not cos x, it is cos x plus y. mean x plus y entire function should be considered as x. Okay, so differentiating with respect to x, this is x is 1, y differentiation x is differentiation 1, y remaining same, plus x remaining same, y is dy dx is equal to cos function is minus sine function is x plus y into the same rule, use the same rule, x differentiation 1 and y differentiation dy dx. Then complete the product and dy dx term shift to the left hand side. So y plus x dy dx is equal to minus sin x plus y, then minus sin x plus y into dy dx. Then dy dx term shifted to the left and taking common dy dx. From here x will be there, and from this term positive, because it is negative on the right hand side, so left hand side positive, sin x plus y is equal to this positive y shifted to the right, so now minus y and minus sin x plus y. But just divide it, dy dx, minus is common, so y plus sin x plus y and divided by this term, and it completes the solution of the problem. This question is homework for you, exactly similar to the previous question. Here only sin is there, sin function derivative is cos, and everything, this is cos, and everything will same with this problem. Okay, this is another question, sin square y plus cos xy is equal to pi. So here sin square is outer function is square first, so 2 times of sin y, then differentiation of sin y, sin function is cos, then differentiation of y, that is dy dx, in that way. And here cos is the outer function, cos function derivative is minus sin, xy will remain same, then xy derivation should be written there. Pi is a constant number, will be 0. You see here, differentiating with respect to x, it is 2 sin y, power will come in front and power will be decreased by 1, so 2 sin y, then sin function derivative is cos, because sin y is taken as x, so we should differentiate sin y again, that is cos y, and again it is not x, for y you are to write dy dx here by chain rule. Okay, then cos function, cos xy derivative will be minus sin xy, but xy is considering as x, so into this xy function derivative is x is 1, so it is y remaining same, plus x remaining same, y derivative is dy dx. On the right hand side it will be 0, because pi is constant, so derivative will be 0. Okay, so now just complete the product and take dy dx common only. 2 sin y cos y is nothing but sin twice y, dy dx is already there, this is minus product y sin xy minus x dy dx into sin xy. You do not confuse with this. Some students write it like sin xy square after completion of product. Some students write sin x, this y into y square, xy square, they write xy square, but that is wrong, because this xy is inside sin, but this y is not inside product, it will be product in front of sin. That is why y sin xy, do not write sin xy square. Some student may get confused here, so that is the reason. And plus it is minus, here also do not write sin x square y, because this x is not, will not go to the inside sin, it is outer function, so x dy dx and then sin xy equal to 0, then dy dx is common, and rest of the part you know that dy dx common, here sin twice y and here x sin xy, and on the right side this term will be shifted, y sin xy, then divided only, and this completes the solution of the problem. Okay, so next question, number 14. 10x plus y plus 10x minus y is equal to 1. Homework, it is simple question. 10 function derivative is what? Sec square x plus y, and then x plus y is treating as x, so differentiation of x plus y will be 1 plus dy dx. It is like this, you see here, it is like this. First of all, 10 function derivative is sec square x plus y, and x plus y is considering as constant, so by chain rule x derivative is 1 and y derivative is dy dx, you write this. dy dx. Is that clear? And in the second part, mean this part, in the second part, mean this part, 10x plus minus y, that is sec square x minus y, it is 1 minus dy dx. Okay, and right hand side constant number, derivative will be 0. Then complete those product and take common dy dx. And from there you will get the answer for the question, and I think you can solve this problem. Okay, this is another homework for you. Sin x plus 2 cos square y plus xy is equal to a cube. Very simple. Sin x derivative cos square derivative 2 will come out, that means 4 cos y, and cos function derivative is minus sin y, and then y function derivative is dy dx. Use same rule here. This is product. So many times we already have written the derivative of xy, you know that one, and a cube is a constant number, so derivative will be 0 only. So you can solve this problem. If you have any confusion with these problems, you ask me, I'll solve for you for the question. And this is another question, similar type question you can solve. This question I am going to solve. 3 sin xy plus 4 cos xy is equal to 5. Very simple. Differentiating with respect to x. You write that line, differentiating with respect to x. So 3 is constant. Sin xy derivative, xy is considering as x. So derivative of sin is cos xy. You see, this is 3 is remaining same. This is cos xy, but xy is treating as x. Therefore, differentiation by the chain rule, xy is x is 1, y will remain same, plus then x remains same, y differentiation is dy dx. Then cos function derivative is minus, so minus is taken already in front of 4, so minus 4 sin xy into, then xy is again y plus x into sin x dy dx. Right hand side 5 constant number, so it is 0 simply. You see, this is y plus x dy dx. Y plus x dy dx can be taken common, this one, and here 3xy will remain, and here minus 4xy will remain. On the right hand side it is 0. Then you see, very sincerely, 3 cos xy minus 4 sin xy, this term should not be equal to 0, because this term is equal to 5, and that is why it cannot be equal to, it should not be taken as 0, because otherwise the answer will not come there, because in that form it is 0 by 0 will be there. Okay, 0 by 0 will be there, so this term cannot be taken as 0. So just divide it by this term, and simply y plus x dy dx will be there, y plus x dy dx will be there, and that will be the solution for the question. Okay, this take this question. If sin y is equal to x into sin a plus y, then prove that dy dx is equal to this. And it is one important question, and previous question is also important. So here you see, though the function is given as like sin y is equal to x into sin a plus y, it is an implicit function of y. You see, y is dependent variable, and that is inside sin here and here also. So actually this is an implicit function, but in this question you can separate x and y. You see, sin y divided by sin a plus y and equal to x. So x is equal to a terms in y. So actually this is this can be treated as an explicit function also. I will discuss later on, but first in usual method I am going to solve this problem. And after that we have only one alternate method for this question also, that will be discussed later on. You see this one, sin y is equal to x into sin a plus y. Okay, so differentiate, simple, differentiating with respect to x. So sin y derivative is cos y, for y dy dx. There are two functions, x into sin a plus y, so x derivative is 1, sin a plus y remaining same, plus x remaining same, sin x a plus y derivative is cos a plus y, and by chain rule a plus y derivative is a0, y is dy dx. Next, dy dx is common, this is cos y, and this term will go to the left hand side and the negative, this is plus, so left hand side is negative, dy dx is taken common, so it is minus x cos a plus y, and this term is already on the right hand side. So dy dx is equal to sin a plus y divided by this one. But this is not the answer. Already we obtained the value of dy dx, but here you see the answer is not this. So what is the work to be done to get this answer? You sincerely see the answer here. You see here no x term is present in the expression for dy dx. No x is present here. But in our answer we have an x here. So now the concept is to remove x, this x, by the help of this equation. Okay? By the help of this equation. You should use this equation to remove this x. Okay? Use this equation. Sorry, you see here I am erasing this. Okay, you see this equation for the value of x. What is the value of x? You see the value of x will be sin y divided by a plus y, sin a plus y. Value of x should be replaced here, you see here. Okay, so use that value. So dy dx is equal to sin a plus y is there, cos y minus this x is already you understood that sin x is equal to sin y divided by sin a plus y, that is here, into cos a plus y is there. Just take LCM sin a plus y, it will go to the numerator. This sin a plus y will go to the numerator. You see here, this after taking LCM, this sin a plus y will go to the numerator and product. So it will be sin square a plus y, and taking LCM here, it will be sin a plus y into cos y, then minus cos a plus y into sin y. You see that line? This one, after taking LCM, it is going to the right numerator. So it is sin square, it is sin a plus y into cos y minus cos a plus y into sin y, and this is a formula, sin a cos b minus cos a sin b. So sin square a plus y, it is sin of a minus b formula, so it is a plus y minus y, y and y will get cancelled, and so the result is sin square a plus y by sin y, and this is the solution for the question. But this question can also be solved by another method. You see, this is one alternative method for solution for the question. I already told you that this function can be expressed as a function of y. You see, x is equal to, it is a function of y, this sin y divided by sin a plus y. So x is equal to some expression for y. So now it is an explicit function. So dy, you should differentiate with respect to y, not with respect to x, because if you take with respect to x, then the left hand side will be 1 and right hand side in all terms, because sin y, so there will come a dy dx. Here also differentiation, there will come dy dx terms. So that is why you should not differentiate with respect to x, you differentiate with respect to y. That is why it is dx dy. Okay, so is equal to, denominator is question rule, you know that one, denominator is square, then denominator into derivative of the numerator, cos y, because sin y derivative is cos y, then minus cos a plus y will be there for the derivative of denominator, and sin y is already here. And now you see this is a formula, sin a cos b minus cos a sin b. So dy dx is equal to, this is formula, use that formula, sin a plus 1, sin a minus b formula, and y is cancelled, so will remain only sin a, and but we need dx dy, so write the reciprocal, it is dx dy, I am writing here dy dx, so this term will go to the numerator and this whole term, result of this whole term is coming to the denominator. It is sin A only. I am skipping one line here only, so you can understand that line. So this is one alternative way for finding the differentiation of this problem. Okay. This is one important question. You see, x into root over 1 plus y into root over 1 plus x is equal to 0, then prove that this one. And this question asked in your exam in earlier years, so it is one important question again. You see, in the first side, this function given is an implicit function, because x and y at the first side, you see, you cannot separate this separate x and y, so that is why it is an implicit function. But if you solve this problem in usual method of differentiation, that means directly differentiate this, then the result will come out. No doubt the result will come out, but it is a very tough and tougher one. So that is why for this question we have a particular way to solve this question in some easy way. Do not use the direct method, direct differentiation here, because in that way the problem will be a very big one, very huge calculations will be there. So do not differentiate this function, especially this function, in a usual way. Okay, so before going to solution of this question, we are to modify this function by taking like this. Right hand side is minus 1, take square, whole square here. So x square into root over will cancelled out, it is y square. Positive will be there because squaring on both sides, so y square into y plus x. Complete the products here, it is x square, this minus y square, and it is x square y, this minus y square x equal to 0. Then it is x plus y into x minus y, xy is common here, so it is x minus y. On the right hand side it is 0. So x minus y is taken common, this is x plus y, then plus xy, right hand side is equal to 0. Now be sincere here. From here, which factor is not 0? Which factor is not 0 and which factor may be equal to 0? You just think here. Here you see this x minus y factor is not 0, because if you take x minus y is equal to 0, then you will get, you see here, very simple. You see, if you take x minus y, this factor is equal to 0, then you will get x is equal to, y. But x is equal to y is not satisfying. X is equal to y is not satisfying the equation. You see here, just 1 minute. X is equal to y is not satisfying this given equation, this one. X equal to y is not satisfying this equation, because if you use x equal to y in the left hand side, you will not get 0. You will not get 0. You hear x root over 1 plus x, this is x root over 1 plus x, that means left hand side will give us twice x root over 1 plus x, and that is not 0, mean x is equal to y is not satisfying this equation. Therefore x not equal to y, you see, therefore this x is not equal to y, mean x minus y is not equal to 0. Is that clear? So I am erasing this. Okay, you write here, actually you write here x minus y not equal to 0. You write this line here as your side note. Okay, so from here you can separate y and x now, because y is common here, this y is common, so 1 plus x is there, this x is going to the right hand side, minus x, so y will be equal to minus x by 1 plus x. Now you see this is an explicit function, because x and y is completely separated. Now differentiate it, this one. So differentiating with respect to x, dy dx is equal to, minus is there, use the quotient rule, 1 plus x whole square. So 1 plus x, derivative is of the numerator x is 1 minus the numerator remaining same, derivative of the denominator is equal to 1 again. So completion 1 plus x minus x, plus x minus x is cancelled, so 1 will remain there, minus 1 by 1 plus x square. That is the solution for the question. And this is the completion of this today's class. In the next class I will begin the chapter in derivative of inverse trigonometric function. Okay, so till then, thank you very much.